Differential equations, we are looking at our final question on the 4.4, 4.7 review. It's really a problem from 4.4 with undetermined coefficients. And we're supposed to solve this initial value problem. And, we're going to assume that y equals e to the mx is a solution to the homogeneous differential equation. Pardon me. And that will yield m squared plus 4 equals 0, meaning m squared is equal to negative 4, and if we took plus or minus square roots, we'd get plus or minus 2i. And of course, what you're going to remember is really what we've got is this general solution when you yield complex solutions, imaginaries. So we're going to have e to the 0x, and e to the 0x is just equal to a 1. And we're just going to have c1 cosine of 2x plus c2 sine of 2x. This is our complementary solution, and I should write that as y sub c. Okay? For our particular solution, you can see that we've got x squared, so we're going to assume that there is a general quadratic function, ax squared plus bx plus c, that is going to be a solution. But we also have this e to the x, so I'm going to put a d e to the x right up there. Now this derivative is quite a bit easier than our last problem, thank goodness. We'll just have a 2ax plus b. Of course, the c goes away, and we'll have a d e to the x. We'll take a second derivative, and we'll just have a 2a plus d e to the x. And where we're going here is, well, we're going to have y double prime plus 4 times y is equal to x squared plus 3e to the x. We're going to substitute these terms in. So here we'll have a 2a plus d e to the x plus, well, 4 is going to get multiplied to every one of those terms. So you might as well just distribute that 4 immediately. And tell you what, right over here we'll have x squared. By the way, I really can't stress this enough. You want to think of this as a general quadratic kind of a function on the right-hand side. In other words, there's a 0x and a 0 constant over there. Well, how does that come into play? Well, on the left side, we'll have a 4ax squared. Take a look at any terms with a x in it. That's only going to be here with a 4bx. How about just terms without any x whatsoever? Well, that would be a 2a plus 4c. And then finally, we have a 1d e to the x and a 4d e to the x. That becomes a 5d e to the x. So right now we can do some coefficient analysis and really put some things into play. We can say, well, look, what's in front of your x squared? Well, 1. That means 4a must equal 1, and more to the point, a must equal 1/4. You're going to notice that 4b will have to equal 0, meaning b itself will be 0. 2a plus 4c will also equal 0. So 2 times 1/4 will become 1/2. And we can subtract a 1/2 multiply by 1/4, and we'll get negative 1/8. And then finally, we can say, well, 5d will have to equal a 3, so d will equal 3/5. Now, remember that, our particular solution was, in fact, an ax squared plus bx plus c plus d e to the x. So this means we have 1/4 x squared. The 0 is going to wipe that out. The c is just going to be a minus 1/8. And then our d here is a 3/5. So that's all well and good, but we're not done. You see, we've got our particular solution. We had our complementary solution. But this is an initial value problem. So we still have to do some work to make this come together. So how do we do this? Well, we can say our y is going to be, well, we had our c1 cosine of 2x plus c2 sine of 2x. Then we've got our particular solution. Added on right here. But we had two initial conditions, guys. We had y of 0 equals 0. I'm going to recopy that. And we also had y prime of 0. You look at the top here, that equals 2. And the reason why they're giving this to you is so you may find what C1 and C2 are. Let's just start with y of 0 equals 0. That means x equals 0, y equals 0. I'm going to actually plug that in. The cosine of 0 is just a 1, isn't it? Here C2 gets multiplied to 0. That's gone. 1/4 times 0 squared is gone. Here's a minus 1/8. Be careful, e to the 0 is just a 1. We've got that 3/5. So my goodness, we are so amazingly close to finding C1. Look, if we got a common denominator real quickly here, we could multiply by 5 over 5. Here we could multiply by 8 over 8. And we really have 24 minus 5. So that's going to be a 19 over 40. And that means C1 is actually negative 19 over 40. But here we are with our y. Let's go ahead and take our derivative. Y prime, well, the derivative of cosine is negative sine, but we need the chain rule here. The derivative of sine is just cosine, but we need the chain rule once again. Here we can bring down a 2, and we'd get 1/2 x. Derivative of negative 1/8, well, that goes away. And then we'll have a 3/5 e to the x. And now we're going to use y prime of 0 is equal to 2. That means let x equal 0 and y prime will equal a 2. So left side becomes a 2. Again, the sine of 0 is 0, so this just becomes a 0. The cosine of 0 is just a 1. 1/2 times 0 is 0, that's good. And then we'll just have this 3/5 times a 1. So let's just see where we're going here. We can subtract a 3/5. And this is 10/5 minus 3/5. Well, that's 7/5. And that means that C2, if you divide both sides by 2, or if you multiply by a half, C2 would be 7/10. So look at the top of the screen, guys. Now you know what C1 and C2 really are. And that means that we can write our final answer. C1 is negative 19 over 40, cosine of 2x. C2 is 7/10 sine of 2x. And look at that. Here we are wrapping it all up. So expect to see some problems like this on your final summative. I hope this helps. Best of luck to you.